In this podcast, we're going to talk about solution concentrations. All right, firstly, let's talk about mass percent. Mass percent is just going to be the ratio of the mass units of solute to the total mass units of the solution. So basically, it's the mass of the solute divided by the mass of the solution, and then you multiply by 100 to get the percentage. Okay, when we're dealing with solution concentrations, we're often asked to go from milliliters to grams and such so that we can go between different concentration units. To simplify this process, we're going to assume that 1 milliliter of water is equal to 1 gram of water because the density of water is 1 gram per milliliter. It's not exactly true, but it is a close enough assumption. So if we have 1,000 milliliters of water, that'll be 1 liter, which will be 1,000 grams. All right, the next unit that you'll have to deal with will be mole fractions. You are familiar with the concept of mole fractions, but now we're just going to apply it to a solution. So basically, it's the moles of the solute to the total moles of the solution. And then we have molarity. Molarity is the most common unit for solutions. It's the ratio of moles of solute to liters of solution. And here we see a problem involving molarity. It wants us to use molarity in this case as a conversion factor. So we are given the problem how many grams of sodium chloride are needed to prepare 1.5 liters of 0.5 molar NaCl solution. So we need to think about what volume we're going to prepare, what molarity we have of that solution, and then what does the molar mass of the solution. Okay, so to start this problem, you should start with the 1.5 liters. Okay, and we're going to use our 0.5 molar as a conversion factor. We just learned that 0.5 molar is really the same as 0.5 moles over 1 liter. Okay, so if we have 1.5 liters, we can use this right here as a conversion factor, just like we do 1 mole is equal to 22.414 and all that good stuff. I don't know why I put an equal sign there. You don't need an equal. Ooh, okay. Okay, so we're going to use this 0.5 moles over 1 liter as a conversion factor. So we have liters on top. So we'll put the 1 liter on bottom, the 0.5 moles on top. Now that's just going to get us to moles, and we want grams. So we're going to keep going with this conversion to get to grams. So we know that 1 mole is equal to the molar mass in grams. And if you add the masses of Na and Cl, you'll get 58.443. Okay, and that'll tell us how many grams. So in this case, we're going to use molarity as a conversion factor. Okay, and when I solve this one, let's see, find my answer. I got 43.8 grams. Okay, so molarity can be a conversion factor, okay? And there's one last unit of concentration that we need to look at, and it's called molality. Now, molality is represented by a little m, whereas molarity is represented by a capital M. Molality is the moles of solute over the kilogram of solvent. Now, when you're thinking back, we made the assumption that 1 milliliter of water, which is usually the solvent we're dealing with, is equal to 1 gram. So this really, you might be questioning, well, what's really the point in having molarity and molality? Molarity is liters. Molality, you're dealing with kilograms of solvent. So what's really the point? Well, the point is when you have a significant temperature change in your experiment, molality is a better way to go because when you increase the temperature of a solution, that also affects the volume of a solution. So your molarity reading may not be exactly the most accurate way to go because as the solution heats up, it's going to expand, and as it cools, it's going to get smaller, compress. Okay, so it's actually better to use molality in these cases where you're going to be having a significant temperature change. Okay, so that's the big difference between the two. All right, now let's apply some of these definitions that we just got. So we have a problem here, wants us to assume that we have 2.5 grams of malic acid and a half a liter of water, which is going to be 500 grams. Wants us to calculate the molarity, molality, mole fraction, and mass percent or weight percent of the acid in the solution. Okay, well, in order to tackle this problem, I suggest that you make a chart. Okay, so I make a chart where I put moles and grams, and I'm going to figure that out for my solute, my solvent, and my total solution. Okay, well, we are given a little bit of information already. We know that we have 2.5 grams of malic acid, which is going to be your solute. So we can go ahead and fill in that. We also know that we have 500 grams of solution, of water, excuse me, of solvent. So we're going to go ahead and put that in. So we can go ahead and get this whole bottom row filled out here. Okay, and then if you add those together to get the total solution, you get that. Okay, all right, now we need to convert all these to moles so that we can figure out the moles of solute, solvent, and solution. And then we can work on the molarity, molality, mole fraction, and weight percentage. All right, so we have 2.5 grams of malic acid. Do we need to get it to moles? So we're going to divide by the molar mass. So we'll need to do C times 4, H times 6, and O times 5. When I did that, I got 134.0914 grams is 1 mole of malic acid, which told me that I had 0.018644 moles of malic acid. Okay, so I'm going to go put that up here in my little chart. Okay, now I need to find out how many moles of solvent I have. Okay, so that's going to be water. And we have 500 grams of water. And then we know the molar mass of water is 18.0158, 1 mole. All right, and when we calculate that out, it tells us that we have 27.753 moles of water. All right, and then if you add these two numbers to get the total for the solution, we get 27.7721. Okay? All right, now I'm going to extend the page a little bit so we've got a little bit more room to work here. Okay. All right, so first let's tackle all right, not really sure why I have this little blue line, but we're just going to go with it. So just ignore my blue line. Okay, so first we can tackle, let's see. We can start with molarity. Molarity is pretty simple. That's just going to be our moles of solute over the liters of solvent. So solute moles, we have 0.018644. And we were told in the problem, if we scroll back up a little bit, you shall see that we had a half liter of water. So 0.5 liters. Okay. And we get 0.073 molarity, okay, molal. Okay, so that's our concentration right there. Okay, so 0.0373 molar. All right, now let's look at molality. All right, molality is going to be our little m, and that's going to be moles of solute. So it's going to be our same number here. Man, I don't know why it keeps making a Y when I do that. Okay. All right, so there's our moles, and we want over kilograms of solvent now. We had 500 grams, and then if you look at King Henry, to get it back to kilograms, we're going to move 3 places to the left, so that leaves us at 0.5 kilograms. Okay, so over 0.5 kg, and we're going to get the same exact thing. Okay, so 0.037 molal, 0.0373 molar. Okay, all right, now let's look at percentage. All right, percentage is going to be the grams of the solute over the total grams. So we got 2.5 grams over 502.5 grams. All right, and then we got to multiply it by 100. Okay, and when we do that, we get 0.5%. So 0. I don't know why it's dragging so bad tonight. Man, really bad. Gotta love technology, folks. All right, so 0.5%, that's going to be our percentage. And then the last thing we want to look at is our mole fraction, in which case we're going to do the total mole, or the solute moles over the total moles. So we're going to do 0.018644 over the 27.7721. Okay, so here's our little insignia for mole fraction. All right, we're going to do our moles. So 0.18644 over our total, which was 77.7721. Okay, and our mole fraction is 6.7 times 10 to the negative fourth. Okay, so very small amount because we had a very small solute amount. Okay, so that's how you have to break it down. So first make you a chart, moles, grams, solute, solvent, solution, total. Get up all these values, and then you can just plug it into your equations. Makes life way easier. All right, and the last one is going to be our serial dilution. So when you're trying to dilute a concentrated, like 11.6 molar solution, to something a little less concentrated, like 3 molar, you need an equation to help you do that. So we have molarity, or the concentration of the stock, and the volume of the stock equal to the concentration, or molar, of the dilute times the volume of the dilute. You often see this equation written as M1V1 equal M2V2. Okay, so that's a common way you see this equation. All right, so in this case, we're going to use 11.6 molar. We need to know how much of that stock do we need, so we're going to leave our V stock open, or our V1 open. We know we want a 3 molar solution, and we want to make 250 milliliters of it, which when you convert is 0.25 liters. Okay, so then we do our math. So we got 3 times 0.25 divided by 11.6. So we need 0.065 liters, which works out to 65 milliliters if you were to convert it back. Okay, so you may need to know how to do dilution problems as well.